Each year, millions flock to the California coast. Some may come for the waves, others for the views or a sense of peace. Whatever the reason, there's a little something for everyone. However, in the background of it all, there is a secret battle, one between the sea and the land which you stand on. It's a relentless game of tug-of-war, one where the sea endlessly adds, but more often than not, picks up rock and sand and carries it out to sea. The constant exposure to harsh conditions leads the bluffs to crumble and the shorelines to be pushed landwards. Unfortunately, people love living on the coast, which can lead to a dangerous predicament if the coast creeps out far enough to erode the ground beneath the roads and the buildings. As National Geographic defines it, erosion is the geologic process in which earthen materials are worn away and transported by natural forces such as wind, water, or ice. Water is a main component for erosion. There are 4 stages involved in water erosion. There is splash erosion, for when raindrops initially land and dislodge the soil. Sheet erosion, where water runoff carries particles away. Rill erosion, in which the runoff begins to form thin, discrete streams. And gully erosions is the widened version of a rill, and it's big enough to transfer sediments. The steepness of the topography, amount and velocity of the water, and how much vegetation in the area all affect the amount of soil displaced. Because of how bluffs, cliffs, and beaches themselves are in constant exposure to waves and wind, it's no wonder that coastal erosion rates are so high. While erosion in Sierra Nevada might wear down a rock at less than 1/10 of a millimeter per year, sea cliffs can retreat an average of 30 centimeters annually. That's more than 500 times faster. Now, imagine 4 types of coastline. A flat sandy beach, a steep and sandy beach, a bluff with beaches, and a bluff without a beach. They all deal with the same coastal conditions, but some types of topography are more resistive and some are more erosive. First, flat sandy beaches. They are the most resistant, as waves tend to break further away from shore, reducing the force of the waves. Steep sandy beaches are slightly more vulnerable, as the waves break a little higher up on the shore. Bluffs with beaches. Bluffs are the most vulnerable, but the rocks and sand form a barrier that reduce the force. And bluffs without the beaches are most fragile, lacking any buffer at all. According to Tsugo Sonomura, when waves strike a sea cliff with enough force to overcome the rock's resistive force, it will carve a notch into its base. This undermines the cliff above, causing it to shed rock and sediment. The fallen debris briefly accelerates erosion, as the small pebbles are churned by the waves acting as a form of sandpaper. But over time, as more and more sediment accumulates, it will begin to absorb the wave's energy and slow down further erosion. Eventually, this will result in a steep cliff becoming a gentler slope. The Bureau of Land Management cites that California is home to 1,100 miles of coastline, the most of all of the mainline U.S. states. According to Gary B. Griggs, a marine scientist from the University of California, Santa Cruz, between 1945 and 1978, there was what was called a cool Pacific Decadal Oscillation Cycle, or a PDO. In a cool PDO cycle is categorized by calm ocean currents and a slower rate of coastal erosion. Coincidentally, during this time, California's population doubled, leading to people building too close to the shoreline. After 1978, a warm PDO cycle began. It has rougher seas, more violent storms, and a higher rate of coastal erosion, which was able to push the shoreline landwards, putting all the infrastructure built there in danger. One well-cited example of the magnitude of shoreline migration is the Cape Hatteras Lighthouse in North Carolina. It was originally built 1,500 feet inland in 1870, but quickly it became evident that the shoreline was rapidly approaching. By 1919, the sea was 300 feet away from the lighthouse, and soon after, by 1934, it had reached the lighthouse. Local government tried everything to hold the sea back for the next 60 years with dikes, breakwaters, and wooden revetments, but none were a good long-term solution. So ultimately, in 1999, the National Park Service relocated the lighthouse 2,900 feet further inland. If you're wondering why this matters, as it may seem like only rich people would suffer when their beach houses collapse and flood, but this is an issue that affects the entire town. Due to climate change, the sea level rise is projected to increase, along with the rate of coastal erosion. And a common way of combating this is by replacing the eroded sand in a process known as beach nourishment. While it preserves the beauty and can boost local economies via tourism, this is a short-term solution. The price and demand of sand is steadily rising. It currently costs around $12,000 per kilometer worth of sand. But by 2050, it's projected that a kilometer worth of sand will cost closer to $62,000. This exceedingly expensive expenditure is then pushed onto the town's communities, increasing rent and food prices. This economic demand will be bad for everybody involved, but especially the poorer communities who are least capable of handling these sudden changes. So, what can we do? The only long-term solution available is to pack up your bags and move away from the coast. Let the sea do its natural thing. But people are not eager to do so, as you'll have to move everything inland: houses, businesses, roads, walkways. And because people are simply attached to their home and community, they don't want to leave. So what we try to do is armor these shores with breakwaters to soften the force of the waves, sea walls, and natural solutions such as mangroves, which are actually a pretty good solution as it is more cost effective and slows erosion rates. But none of these solutions are permanent. They all need maintenance. Currently, the city of Santa Cruz plans to continue maintaining existing revetments and beach nourishment projects, but ultimately they plan to remove the armory and retreat inland. Sounds like a pretty great plan to me. It preserves the coastline, giving people ample time to move away. It's more cost effective as there's no maintenance involved. And ultimately, because one up against the sea, ocean always wins.